unit is purely related to properties of surfaces and solids. So if I consider a property, right, of any surface, right, usually we will call the material, what type of material and other things. But other than this, there are some important properties, that is centroid and moment of inertia. These are the two important properties which deals with mainly related with all your applications, right? So you can able to see in your home, if you have a beam, right? If you have a beam, why it is rectangular section, right? Why can't be a circular one, something like that, right? So all the beams, or if you have any, we can say railway track or something like that. Even the railway track is high type of a section, right? Why it is fit. So it deals with some things. There is some importance in the cross section, right? So the shape of eye, or the shape of a rectangle, or shape of a circle, everything will vary based on different applications. Okay, so that is the importance in this particular unit. So in this, mainly we will discuss about two part. One we call it as centroid, right? So centroid is what is the central location, right, of your particular object, right? So I think we discussed something in UDL, uniformly distributed load. So what happens? We converted that UDL to a point load, and we convert. We identified that the total load will be acting at the center point. Okay. So how to identify that? So we know that for a rectangle it is L by 2. For triangle it is 2h by 3. Something like that, right? So for different other shapes, or some complicated shapes, what will be the centroid location, right? That deals with the first part, and the second part is moment of resistance, or moment of inertia, right? Moment of inertia. So this is also an important topic, that you have to identify what will be the moment of inertia of a particular object, right? So inertia is resistance. So it is giving some resistance because of bending and other things, right? So what will be the inertia for different cross section, right? So these are the two different topics we'll be dealing with it. The first part is centroid, and the second part is moment of inertia, right? That is what it is. It is purely a formula based unit, where you have to know a set of formulas, right? So you have to look it up, what are the different type of formulas for the triangle, for different simple shapes. So you can consider a rectangle or a triangle or a semicircle. For different shapes, simple shapes, you should know what will be the formula, right? Okay. So most of the strength of a particular component, right, deals with the cross section, right? So other than the other material properties, so the strength is purely depends on the cross section of a particular object, right? So these are the different cross sections, right? If I say cross section, what do you mean by that? So for example, this is my beam. It's my beam. So let me consider it is a simply supported beam, something like this. So when you look in front view, you can able to see it is a rectangle, right? But if you look on the side view, right side view, it may be a circle, which means that the cross section is a circle, right? It's a cylinder. It's a cylinder resting on a particular two supports, right? That is a cross section. Or it may also have a T type of section. Right side view, you may have different sections. It may be a T, but in front view, you can able to see as only a rectangle. Maybe for a T, you get this line also, additional line indicating this point. Okay, so something like this. But most of the cases, it looks like a rectangle, but when you look on the right side or left side of a particular object, you can be able to see what will be the cross section, so that you can imagine what will be the three-dimensional object for this, right? Whether it's a cylinder or a cuboid or whatever it is, right? So purely your beam depends on this particular cross section. Right? If it is a cylinder, it reacts differently. If it's a rectangle, it reacts differently. Okay. So the importance is the cross section. Okay. So the importance is the cross section. So this cross section will have a center point or center of mass. Okay. If I consider the beam, so the center. So the self weight of the beam will be acting in the center. Right. You have to identify what is the center point. Right. So mostly it is a point where the weighted relative position, right, of a distributed mass is sums equal to 0, which means that whatever I consider, if I add everything, it will at a particular point, that point will be considered. So that the distributed mass will be, you need to consider the distributed mass. Okay. So it is mainly a balanced one, right? It is mainly a balanced one. So depends on a particular object. For example, if I consider this, so you can able to see a picture, right? So you can hold a particular doll like this, right, in a single point. What happens? This is balanced properly, right? It is balanced properly, which means that the entire weight is acting only at the center point, right? So the entire weight is acting at that nib, at the tip, whatever it is, right? So this is a pure application for some the center point, how the center point is located. Okay, right. So there are two different categories. One we call it as a centroid, other we call it as a center of gravity. Right? There is a difference. Centroid is a 2D, is a two-dimensional approach. Right? So center of gravity is a 3D. Right? It relates with mass, right? Whereas the centroid relates with area, right? So this is purely it depends on area, right? Whereas center of gravity, right? Center of gravity is COG, right? So that deals with mass of a system, right? So this is the entire mass, and it is of course a three-dimensional approach. Okay, right? So it is related with area. So you no need to consider that as a center of gravity. Center of gravity is different, centroid is different. It is purely the cross-section area alone. It's a two-dimensional, right? So it is also called as first moment of an area, right? It is also called as first moment of an area. So we have taken moment of a force, right? So we have taken moment of a force. What is the formula? Force into perpendicular distance. Right? That is what we identify. Right? So if I take moment of an area, we take moment of an area, which means that area into perpendicular distance. Right? Area at a particular location, area into perpendicular distance. Then you can able to locate your centroid. Right? You can easily able to locate your centroid. Okay. So mostly it is the average position of all the points in a particular shape, right? So the center of gravity, it is purely depends on three dimension. So total weight or mass which is acting on a particular space, and the resultant mass is the center of gravity, right? So I can able to see that. So what will happen to a center of gravity? So if you are standing and if you are bending, right? So the location of the center of gravity will change, right? So you think about it in three dimension, right? How it is changing. Okay, right. So now we will discuss about the centroid, right? Which is first moment of area, right? How to take this first moment of area, right? So it is nothing but instead of force, you have area. So area into distance, right? So it is also the main purpose to determine the central of a particular object. So what we discussed, right? It is one of the application to identify the center of the uh, any object, random string. Can I consider here? So let me consider that you have a rod, right? The entire weight of the rod is acting at W, we consider. And let me consider that the distance from this point, let me consider this point as O. The distance from O, let me call it as X bar, right? So if I want to identify what is the centroid for this particular rod, so what I can do, I will take a small strip. Let me consider the small strip, which is DW, right? The location of this DW, so from O is X. So this is X and something like this, right? The symbol is like this. It is also X bar, so we will indicate like this, right? So what I do, I'm going to take, so W is the weight of the whole object, dW is the weight of the strip, whatever I consider. So you know that if I want what is the weight W, that is equal to, right, integral of dW. Right? So if I integrate the weight of the strip with respect to 0 to X bar or whatever it is, right, I will be able to get what is my W. Right? So now you can able to see that the location, you can identify the location by taking moment. Right? Let me take moment at point O. We take moment at point O. So what I am going to get? Right? If I take moment at point O, so X bar, so force W is the force, distance is X bar. So W into X bar is equal to integral, so dW into X bar, this X bar. Okay? So from this I can able to get what is my X bar. X bar is in just nothing but integral X bar into dW divided by this W. I can also write it as integral dW. We can able to get it in this equation, equation 1. I'm substituting here. So you're getting something like this, right? Now I can also replace this dW as area, right? What I'll get? I will get X bar is equal to integral X bar, so X bar into dA divided by integral dA. I'm replacing this dW. So W is the weight. So instead of weight, right, I'm changing it to area. So this one, what you'll get? This is centroid. Sorry, center of gravity. This is center of gravity. This is centroid. Right? Hope you can understand. So W is the weight. So whenever you deal with weight or mass, you will get center of gravity. Instead of weight, if I replace it with area, then I will get centroid. Right? Any clarification in this?
No, sir.
Yeah. So similarly, I can also identify for y direction and z direction. You will get some similar to them. So X bar is integral X into dW by dA. So all are center of gravities, right? Identify center of gravity is the location with respect to x-axis, y-axis, and z-axis, where the center point, where the entire weight is acting. Okay, so which I can write it as X bar dW by integral dW, similarly y bar and z bar. Right, we get overall center of gravity for this particular object. Right. Okay. So the center of gravity, previously it was W. Now we are considering as mass. That's it. Right. So instead of dW, if I consider what is your mass of a particular object, dm, again you will get center of gravity. This is also center of gravity. Center of mass, right? They will call the center of mass, right? So this is another part, and this is center of volume. So center of a volume. So to identify what is the location, center location of a particular volume. So all this relates with center of gravity. No need to get confused why there are lots of terms. Right? So everything relates with center of gravity, right? Nothing else. Okay. So if I consider centroid of an area, so that's what centroid. Centroid of an area, we will consider the A, right? We will consider the A and we will substitute it accordingly. Right? What is the value of A with respect to this? Okay. Right. So now, if I want to identify, right? If I want to identify what is the centroid of any shape, right? What I will do, I have to use this formulas. So the integration formula. So by x bar is equal to integral x element strip. So what is the centroidal location of the elemental strip into A divided by integral B. Similarly, if I want y bar is also integral uh, elemental strip with respect to y into A divided by integral d. Right? We use this formula to identify centroid for different shapes, simple shapes. Okay, so it may be something like this, right? A parabolic shape, right? Something. So you can able to consider a vertical strip or an horizontal strip so that you can identify what is your values with respect to that. Okay. So whenever you want to identify centroid, right? The centroid is what we call it as a first moment of area. It is first moment of area. So that is what we discussed last class, right? To identify this centroid, right, at any location, we have taken a moment with respect to that, and we got something. So we got it in terms of formula. What we got? We got x bar. If I want x bar will be equal to integral x of elemental strip into dA divided by integral dA, right? So this is the centroid if I want with respect to x-axis, what is the location. Similarly, if I want y bar, so y bar is again integral y elemental strip, right, into dA divided by integral dA, right? So this is the formula related to that. So if I want to identify centroid for any irregular shape, right, we can use this formula to identify it. Okay, we will go one by one. So we will try to identify what is the centroid for a rectangle and a triangle and then a semicircle and also a parabolic type of approach, right? So all by means of this integration approach. Okay, right. Let me consider. So let me have a little bit xy axis. Okay, in this xy axis, I am having a rectangle. Okay, so let me consider I have a rectangle with respect to this. Okay, so it's my xy axis. I am having a rectangle like this. Okay, so let me consider B is my breadth of my rectangle and H is my height of my rectangle, right? So if I want to identify what is the uh, area and the centroid for this particular rectangle, what I'm going to do is I'm going to consider a small strip. Okay, so let me consider I have a strip, an horizontal strip, something like this. Sorry, a vertical strip, something like this. So let me consider this is my strip with respect to it, right? So the dimension, so what is the thickness of the strip? Let me consider dx. Okay, and the distance with respect to this, let me call it as x. So this is my distance x. Okay, so what I'm going to do is I'm going to identify what is the value of this dx, and I'm going to integrate with respect to this x, so which means from 0 to b. If I integrate it, I will get the what is the value of it. Okay, so let us identify what is this area of this strip. Area of this strip, right? So which is dA. So this dA is you have dx. Dx is my what you can say thickness, and my h is my height. Okay, h into dx. So this is nothing but h into dx. So dA is nothing but so height of the stick into thickness. So that is my dA, right? So in that case, I can able to identify what is the integral dA. So my integral is from 0 to b. So because I have to increase the step to 0b, so it is from 0 to b. So my limit is from 0 to b. In that case, I can integrate this integral 0 to b h into dx, right? So what will get? So I will get h. It's a common term. It's a constant. I can take it out. So integral dx, I will get x, right? My limit is from 0 to b. So what I'll get? Integral dA is nothing but the area of the entire triangle rectangle, which is h into b. So RBH, right? This is my first equation. Right now, I got what is this integral dA. So this part is over. The next, I want to identify what is my x bar, right? So I want to identify what is my x elemental step. So my x elemental step is nothing but x plus dx by 2. Actually, it is x plus the center point of this. So I am taking moment. That is what we are getting dx by 2. But this is approximated. So instead of this, I can write as x. Dx is a small value. Dx by 2 is very, very small, which meant I can eliminate this term. So I will get approximately 0. So I will get only x. So approximately it is x. That is my elemental step. So now my aim is to identify integral 0 to b x elemental step into dA. I have to identify that. Okay. So that is the formula, x elemental step into dA, right? So which I can write as integral 0 to b x elemental step is nothing but x. dA we know that it is h into dx, which we identified. So let me consider this h into dx. So what I get? I will take that h outside. So it is integral 0 to b x dx. So which if I integrate, I will get x integrating, I will get x square by 2, right? Under the limit 0 to 2. So what will get? So in this, I can able to get as b square h by 2. So b square. So substituting the upper limit, b square. So lower limit is 0. So b square by 2 into h. So this is what I am getting. So this is x elemental step into dA. This is my equation 2. Right? So to identify my centroid x bar is nothing but equation 1 divided by, sorry, equation 2 divided by equation 1, right? This is nothing but what we indicated here. So x elemental step divided into dA divided by integral dA, right? That is what we are going to identify. So which is equal to, so b square h by 2 divided by, this is bh, right? So which means my x bar will be equal to d by, right? So this is my equation 1. So this is my first equation. Okay. So now if I want to identify what is my y elemental step, right? My y elemental step is the distance from here to here. Right? So it is the distance from here to here. This is my y elemental step, right? Which is nothing but h by 2, right? Half of the distance, right? Half of the distance. So in R, you can also take a strip with respect to x-axis. Let me consider dy. You can solve in that way also. It doesn't matter. Okay. So if we do that, what you'll get? You will get. I'm not going to solve this because rectangle, you know that it is off. So you don't need to have more concentration in this. So if we do that, you will get y bar is equal to h by 2. Right? This is what I will get. Right? So where x, so x bar is the center point of this, right? So which means what it indicates here. So if I have a rectangle, my center point of this rectangle is at a distance of b by 2 and at a distance of h by 2. Right? That is what we are indicating here. Right? So x bar is x-axis distance, y bar is y-axis distance. Right? So you will get something like this. Now we will proceed with the same for a triangle. Right? We will go for a triangle. You consider you have a triangle like this. Right? So let me consider this is my axis. Right? This is my center point of the axis, which is this is my x-axis and this is my y-axis. Right? So and let me consider you have a breadth b, right, and height h. Right? So similar way, I'm going to consider a strip here. So let me consider you have a strip here. So something like this. Okay, this is my elemental strip. Okay. So let me consider this elemental strip. I don't know. So I can't put directly h because previously it's a rectangle. Now it is reducing, right? So it is something else, right? This is something else. So let me consider h1. Right? Let me consider this distance as h1. Okay, and let me consider from here to here, the distance is x. Right? So my aim is to identify what is my x bar. Right? We know that the formula is integral x elemental strip into dA divided by integral dA. Right? Okay. The first step is let us identify. Right? Let us identify what is my x elemental strip, and I need a relation with respect to this h1. I need a relation with respect to this h1. So then only I can easily solve this. Okay, h1 in terms of x. Okay, so you consider here, you can able to see here there are two triangles. So one triangle is like this, right? Another triangle, a bigger triangle like this, right? So this triangle is inside this. Okay, so this is my h1, this is my x, this is my b, and this is my h. So you know that according to similarity triangles, base divided by the smaller triangle base is equal to height divided by the smaller triangle height. I can equate it, which means I can write as b by x is equal to h by h1. Right? I need what is the term in terms of h1, which means h1 is equal to h by b into x. Right? h1 is nothing but h by b into x. This is my equation. Right? This is what I got the relation. This is what I want. I'm getting in terms of h1. Okay. Right. So now what I'm going to do is I'm going to integrate. So I'm going to identify integral du. What is my limit? So I have taken a vertical strip. So it means my limit is from 0 to b. Right? It starts from 0 and goes up to p. So my limit is from 0 to b. Right? So which is equal to what is dA? So I want to identify what is dA. Right? So I will do it here. Right? I'll put it here. So what is dA? So dA is area of this strip, right? Which is this is dx, right? This is dx. A small strip is dx, and my area is h into dx. So it is very small. h1 into dx. Sorry, h1 into dx. This is my area of my strip. So which means here I can write it here. It is 0 to b h1 into dx. But I know what is h1, right? In terms of x, integral 0 to b h1 is h by bx into dx, right? So which means I can take this h by b common, integral 0 to b x dx. Integrating x dx, what will get? I'll get x square by 2. My limit is from 0 to b. If I apply my limit, what will get? We'll get h by b b square by 2, right? Minus 0. So when I apply this other term. So which means integral dA is nothing but half into base into height. So it is nothing but the area of your triangle, right? Half into base into height. So you can cancel it, you'll get something like this. This is my equation 1. Now, my next step is I have to identify what is your elemental strip. So integral x elemental strip into dA. Let me go in terms of this, right? What is my x elemental strip? So x elemental strip is nothing but x. It is nothing but x. So which means I can write here this as integral 0 to b x into dA. dA I already identified is nothing but h1 into dx. h1 into dx. Which in turn I can write it as integral 0 to b x. h1 is h by b into x, right? h by b into x into dx, right? So which I can write it as integral. So I will take the common term outside. H by b is a common term. Integral 0 to b x square dx. Right, this is what I am getting. So integrating it, what will get? So h by b integrating, we will get x cubed by 3 under the limit 0 to b. Right? So which is equal to b square h by 3. This is what I am getting. Right, when I substitute it. So b square, so this b gets cancelled, you will get b square h divided by 3. Right? So integral x elemental strip into dA is what I am getting as b square h by 2. This is equation number 2. Now we want x bar. X bar is nothing but equation 2 divided by equation 1. Right? So equation 2 is b square h by 3 into equation 1 is nothing but your area of your triangle half into base into height. So since I'm writing in numerator, you know that it will go in the top. So whatever in denominator will be in numerator. So 2 divided by bh. Right? So getting cancelled, you can able to see that this gets cancelled. So which means I will get x bar is equal to 2 by 3 into d. Right? So my x bar is nothing but 2/3 of d. Right? From the apex, it is 2/3. Right? So this is my first part. Any doubt on this? Now we'll proceed with your y bar. Right? So what is my y bar? So y bar is y elemental strip into dA divided by integral dA. Right? So let us identify what is y elemental strip. So my y elemental strip is nothing but, you can able to see that this is my y elemental strip. Right? YEL. So YEL is nothing but h by 2, h1 by 2. Sorry, it is nothing but h1 by 2. I can write it here. So my YEL is equal to h1 by 2. Right? Which means my YEL is nothing but is equal to h1. You know that it is h by b into x. Right? H by b into x. So which means h by 2b into x. So this is my y elemental strip. Already we identify what is integral dA, so no need to identify again. Directly we can proceed with that. So I'm not changing the strip. So make sure I'm not changing the strip. Right? My strip is vertical. So again my limit is from 0 to b. You can also change your strip. You can also try to solve it in different way. you'll get the same answer. Doesn't matter. But this is somewhat easy, right? Because y element is half of your h1. I can consider that. I can solve it based on that. Okay. So the other approaches, you can also consider a horizontal strip, which is dy, and you can solve in the same way, right? Both are same. Okay. So integral 0 to b y elemental strip into dA is what we are going to identify. It's equal to integral 0 to b, right? So y elemental strip is h by 2b into x. dA, I know already what is dA. So dA is h1 into dx, right? Which means h by b into x into dx. So this is my dA term, right? So I'm going to consider that. Okay. So h by b into x into dx, right? This is my overall term. So which means, so h square by 2b, I can take it out. H square by 2b. So h square 2b, right? Integral 0 to b x square dx is the term I'm getting. So let me integrate it. So we will get x square by 2b. Integrating x square, I will get x cubed by 3. The limit is from 0 to b, right? So what happens if we apply the limit? We will get x square by 2b, b cubed by 3, right? So this becomes 0, right? So which means I will get x square, right? X square b square by 6, right? So this is the term we are getting.
Killer B
Sorry,
square.
sorry, 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 sorry. This is b square. This is b square, right? Sorry, b into b square. So this is also b square. Sorry, yeah. So which means this will be h square b by 6, right? So it is h square b by 6. So this is my second term, the third term. Let me consider. So I will write it directly. So integral 0 to b y elemental strip into dA is equal to x square b by 6. Let me consider this as equation 3. So if I want y bar is equation 3 divided by equation 1, right? It's equal to h square b by 6 into area. So 2 by bh, right? So what I'll get? So you can able to see that these are the things which is getting cancelled. So h, this becomes 3, right? So which means my y bar is nothing but h by 3. Right? This is my equation. So I got what is my x bar, which is 2/3 of b, and my y bar is h by 3. Right? If I draw the triangle, so you can able to see that. So if this is my triangle, right? So my x bar, my location here, this is my centroid point. So my x bar is this. So I use different color because it will be confusing. Right? So my x bar is this, which is 2/3 of b. My y bar is this. This is so similarly, we have two more. So let me consider. You have something like a quarter circle, right? So you have a quarter circle. If I want to identify what is the formula related to this, what is the centroidal location for this quarter circle, right? So what I will do is, it is polar coordinate. It is something like a polar. It means that, so if I consider the strip, this is my strip, right? This is my strip. You can able to see that. Oh, sorry. So this is my strip, which is something like this. Okay. And this strip is d theta, then we consider the angle with respect to this is theta, right? And this is nothing but your radius r. This is nothing but a radius r. Okay. And if you consider here, this is a quarter circle which moves from 0° up to pi by 2, 0 to pi by 2. So the rotation is from 0 to pi by 2. So now if I consider the strip alone, you can able to see that the strip alone is something like this. Looks like a triangle, right? It looks like a triangle. Okay. So the angle is d theta, right? So if I want what is the base of this triangle, it is nothing but r into d theta, right? It's sector, right? It is r into d theta. Height of my triangle is r. Height of my triangle is r. Okay. In that case, you know what is the formula for a triangle. So what is the centroidal location for a triangle, right? So the centroidal location will be here somewhere, right? So the distance with respect to that, so from here to here, right? If I consider, it is nothing but 2/3 of r, right? It is nothing but 2/3 of r, right? So, but there is at an angle of theta, right? So, if I want what is my x elemental strip here, my x elemental strip is x-axis rotation of this, right? Which means it is like uh, resolving it with respect to x. When I resolve it with respect to x, what I will get 2 by 3 r resolving with respect to x is cos theta. Right? This is my x elemental strip. So I want y elemental strip, resolving it with respect to y axis. It is 2 by 3 r. So cos theta will get sin theta. Right? So these are my elemental strips, right, with respect to the locations to identify what is my centroidal points. Right? So what is my dA in this case? dA is area of the strip. If I consider the area of the strip, it's a triangle. So triangle, what is the area of the triangle? It is half into base into height. Half base is r d theta. Height is r, which means dA is nothing but r square by 2 d theta. This is my dA, right? So area of your strip. Okay. So now let us solve the same procedure. We will proceed with the same thing. So I want x bar. X bar is integral x elemental strip into dA divided by integral dA. Right? So let me start with integral dA. So integral dA. So integral dA, my limit is 0 to pi by 2 dA. Right? Which is nothing but, so integral 0 to pi by 2 dA we already identified. This r square by 2 d theta. R square by 2 d theta. So it is equal to, so r square by 2 is a common term. So d theta, if I integrate, I will get theta. My limit is from 0 to pi by 2. Right? So which means integral dA, what will get? Which is equal to r square by 2. So substituting this theta, we'll get again pi by 2. Just nothing but pi r square by 4. Right? This is my equation 1. Right? Of course, a quarter circle. Pi r square is for a full circle. So for a quarter circle, we are getting pi r square by 4. Right? Okay. So now let us go for integral x elemental strip into dA. Right? Which is equal to integral 0 to b. Sorry. 0 to pi by 2. Right? So x elemental strip is 2 by 3 r cos theta. Right? So it is 2 by 3 r cos theta. dA, we know that it is nothing but r square by 2 d theta. So r square by 2 d theta, right? So which I can write as integral 0 to pi by 2, right? So you can able to see that this 2 gets cancelled, right? So you'll get r cube by 3 cos theta d theta, right? So r cube by 3 cos theta d theta, right? So which I can write as is equal to r cube by 3. I can take it out, right? So integral 0 to pi by 2 cos theta d theta. Integrating cos theta, we will get sin theta, right? So r cube by 3. So sin theta, my limit is from 0 to pi by 2, right? So when I apply this, so sin pi by 2 is 1, right? Sin 0 is 0, right? So which means I will get as r cube by 3. That's it, right? So this is my x element of strip into dv. I may consider this as equation 2. So now my x bar is equation 2 divided by equation 1, which is equal to r cube by 3 divided by 1. What is 1? Equation 1. What we got? So 4 pi r square by 4, right? Pi r square by 4. So which means r cube by 3 into 4 by pi r square, right? So if I cancel it, so this gets entirely cancelled. So you get a new formula. So my x bar is nothing but 4r by 3 pi, right? So this is the formula for your x bar, right? Okay, now we'll go for y bar. Same procedure, there's no difference. So integral y elemental strip into dA. It's nothing but integral 0 to pi by 2. Y elemental strip is 2 by 3 r sin theta, right? So you can able to see it. So 2 by 3 r sin theta, right? So which is 2 by 3 r sin theta into dA. You know that we already had r square by 2 d theta. R square by 2 d theta, right? So which means again we get r cube by 3 as a common term. I'm taking out integral 0 to pi by 2 sin theta d theta, right? So integrating sin theta, what you get? You get cos theta. Sorry, minus cos theta. So minus cos theta under the limit 0 to pi by 2, right? So which is equal to r cube by 3 minus, so cos pi by 2 is 0 minus cos 0 is 1, minus or minus, it becomes plus 1, right? So plus 1. So we'll get r cube by, right? So which means same. So your y elemental strip into dA is nothing but r cube by 3. This is my equation 3, right? So in that case, y bar is nothing but equation 3 divided by equation 1. So again, you'll get the same r cube by 3 divided by pi r square by 4. So which means I will get y bar is equal to 4r by 2. Right? Same whatever we discussed. See the location, right? The location of the centroid. So if I consider, right? So if I consider this point, so it is from x-axis. Similarly, with respect to y-axis also, it is 4r by 3, right? So this is what we are getting. Okay, we can start here. So you have to identify what is the centroid for this particular object, right? So they are given what is the equation of this curve. The equation of the curve is y is equal to h into 1 minus k into x cube, right? Something like this. Okay. So my first step is I have to identify what is this constant k, right? So we know that. So y is nothing but h into 1 minus k x cube, right? So let me consider when x is equal to a, when x is equal to a, what is your y? Can you tell me what is your y?
Zero, sir.
Yeah, very good. So when x is equal to a, y is 0, right? Let me substitute in this equation, right? If I substitute it, what will get? So 0 is equal to h into 1 minus k a cube, right? So which means what is my k? What is my k? So k is 1 by a cube. Any doubt on this? So h also is goes on the other side, it becomes 0. So 1 minus k a cube is equal to 0, which means 1 is equal to k a cube. So k is 1 by a cube. Any doubt on this?
No, sir.
Okay. Now I will identify what is my equation now. So my y is equal to h into 1 minus x cube by a cube. Any doubt? I am substituting this k value in this equation, right? So I'll get h is equal to, so y is equal to h into 1 minus x cube into a cube. Okay, this one. Now let us identify what is a small strip. Okay, let us consider the same figure. Right, I'll put it here. Right, so I'm going to consider a small strip. Okay, so let me consider here a small strip here. Okay, so let me consider this strip is dx. It is at a distance of x. Right, it is at a distance of x, and it is having particular value. So let me consider this as 1. Right, because we know what is the equation of this y, so we can easily identify what is this y. Okay, so y is nothing but this one. So what we got, right? That is my vertical distance. Okay, so my vertical distance is right. So let me identify what is my dA. So area of this strip is nothing but y into dx. Area of the strip is nothing but y into dx, which means I can write as dA is equal to y is h into 1 minus x cube by a cube into dx. This is my dA, right? What is my x elemental strip? X elemental strip is x. X elemental strip is x, right? So actually it is x plus dx by 2. Dx by 2 is very small, so I can eliminate it. What is my y elemental strip? Y elemental strip is nothing but y by 2, right? Which means, so my y elemental strip is nothing but h by 2 into 1 minus x cube by a cube into dx. So you know what is my, sorry, not dx. So this is not dx. So y is h into 1 minus x cube by a cube, right? So y by 2. So I am dividing it with respect to that. So I am getting something like this, right? So these are the things. Now we will proceed with the formula, usual formula. So I want x bar. X bar is integral x elemental strip into dA divided by integral dA, right? So we will go one by one. So first, let us identify integral dA. What is my limit for the integral? It starts with 0 and ends at a, because I have taken a vertical strip. Okay, so it is from 0 to a. So this is equal to integral 0 to a. What is dA? We identify h into this that term. I will write that term. So h into 1 minus x cubed by a cube into dx. Right? So let me take the term h outside. So integral 0 to a 1 minus x cubed by a cube into dx. Let me integrate it. Right? So it is equal to h. Integrating 1, I'll get x minus x cube integrating x power 4 by 4 into a cube. So a cube is a common. Limit is from 0 to a. Right? So it will get, so which is equal to h into a minus a power 4 by 4a cube. Right? So which is equal to h a minus, so it is a by 4. Right? Which is equal to, so what you will get? So you will get 3ha by 4. Cleared out of this?
No, sir.
Integral dA. Right? Let me consider this as equation 1. Okay. Next, I'll proceed with integral x elemental strip into dA. Right? Which is equal to integral 0 to b. X elemental strip is x, right? I automatically with x. That's it. So x into that dA term, that entire dA term. So what is the dA term? So h into 1 minus x cube by a cube. H into 1 minus x cube by a cube into dx. Right? So that is equal to h, I will take it out. So integral 0 to b, sorry, yeah, I think it is a, right? So integral 0 to a h is out. So x minus x power 4 by a cube under the limit. So 0 to a, and I will integrate this. H integrating it will get x squared by 2 minus x power 5 by 5 a cube. The limit is 0 to a. Right? Let me substitute it. So what is it? H. So a square by 2 minus again a square by 5. Right? So which is equal to h. I will take LCM. Is 10 a square minus 2a square, right? So what will get? I'll get p a square h by 10. Any doubt on this?
No, sir.
Yes. Okay. So this is my equation 2. Now I'll go for x bar. X bar is 2 divided by 1. Which is equal to 3a square h by 10 into 1. So 1, I have to put 4 by 3. 4 by 3 ah. Is it right? 3 by 4, I'm writing it like this. So 4 by 3 ah. Right? So when you cancel, what are the things that get cancelled? 3 gets cancelled. Right? Next, this term gets cancelled. So only h gets cancelled. So and 4 I think I can divide this 4 as 2, this will be 5, right? So which means my x bar is 2 by 5a. Any doubt on this?
No, sir.
Right. So same, I will proceed with this y element step, right? So if I consider my y element step, again, so it is the equation, let me consider. So integral y element step dA is equal to integral 0 to a. My y element step, we know it is already x by 2 into 1 minus x cube by a cube, right? So h by 2, so 1 minus x cube by a cube into dA. dA is again h into 1 minus x cube by a cube dx. This is my dA, right? So you'll get something like this, which means I'll take 1 by 2 outside. Sorry, I can take x square by 2 outside. So because h into x square by 2, integral 0 to a. So this one I can write as 1 minus x cube by a cube, the whole square dx, right? So now I am going to expand this. So which will get x square by 2 integral 0 to a. So this is nothing but 1 minus 2x cube by a cube. So a minus b the whole square plus x power 6 by a power 6 dx. Now let me integrate this. So when I integrate, I'll get x square by 2. I'll get x minus 2x power 4 by 4a cube, right? Plus x power 7 by 7a power 6, right? Under the limit 0 to a. We substitute it. This is square by 2 a minus. So again, you will get a by 2, right? If I cancel it, a power 4 by a cube will get a. So 2 by 4, I will 1 by 2, right? So a by 2 plus this one, a by 7. Yeah, take an LCM. So what we'll get? We'll get x square by 2, right? So 14 is my LCM, right? So you'll get 14 a minus 7a plus 2a, right? Get out of this. Yeah. So what you are getting? So you'll get x square by 2 into. So 14 plus 2, 16, right? 16 minus 7, right? You're getting 9, right? 9a by 14. Right out of this?
No, sir.
No, sir.
No, sir.
Okay. So this is my equation number 3. Right now, I get y bar. My y bar is equation 3 divided by equation 1. Is equal to, so x square by 2 into 9a by 14 into, so equation 1 is 4 by 3h, right? 4 by 3h. 4 by 3ah. So you can able to see that a get cancelled. 3 goes for 3 here, and this goes for 2, right? And again, this goes for 7. right? And HX goes, so 1H gets eliminated. So you get Y bar is equal to 3 by 7 H. Right? Any doubt in this?
No, sir.
Yeah. So this is how you have to identify what is the values for different sections. So similarly, instead of y is equal to h into 1 minus kx cube, then I can also give it like y is equal to ax square, something like that, a parabolic equation, right? The procedure is same. You can follow the same procedure similarly to identify what is your centroid by integral approach. This is by means of an integral approach, right? So that's it. So we will stop here.